Hi, in this video we're looking at this concept of limiting and excess reactants. Now don't forget, a reactant is an ingredient. It's something on the left side of the equation. And a limiting reactant is something that gets used up first. An excess reactant is something that is left over. So let me kind of show you this visually. Let's say I had this generic equation, A plus B makes AB. And I've got all these A's and B's on the screen here. Let's say this is in a beaker. This reaction starts to take place and AB starts being formed, but then it stops right here. And that's because there's no more A to react. I have plenty of B left over. In fact, we'd call this our excess reactant, and A would be called the limiting reactant. And reactant A is the limiting reactant because it's used up first and therefore limits how much of the product can be made. So that's what a limiting reactant is. It's a reactant that is completely used up before all of the other reactants in a chemical reaction. Now here's a different way to look at this. Let's say I had two reactants on the left, two products on the right. This is all happening in one container. And I just want to kind of use this little bar graph to show the quantities relative to each other of all of these four substances in a beaker. So I start the reaction, I'm producing products, I'm getting rid of reactants because they're turning into products, but it looks like reactant 2 is reacting at a little bit of a faster rate. And oh, we're done. We're done because reactant 2 is gone. It's turned into product 1 and 2 with some sort of combination with reactant 1. That part's irrelevant. What's relevant is the fact that we don't have reactant 2 anymore, so therefore the reaction has stopped. Even though I have an excess amount of reactant 1 and I've got plenty of products, we're done. So reactant 2 is the limiting reactant, and in this case reactant 1 would be considered the excess reactant. So let's do an example problem here. This is ammonia reacting with oxygen to produce nitrogen monoxide and water. And the question says a 2-gram sample of ammonia, so 2 grams of this, is mixed with 4 grams of oxygen, so 4 grams of that. And then it asks which is the limiting reactant. So here's how you do this. Pick a reactant, and it does not matter which reactant you pick. For this example, I'm going to choose oxygen. You could start with NH3 and you'd be getting the same conclusion of which of these two is the limiting reactant. I'm going to start with oxygen. So you pick a reactant, and then what you want to do is calculate how much of the other reactant is used when all of that mass is used up. So if I have 4 grams of O2, I want to do a mass-to-mass stoichiometry calculation to figure out what mass of NH3 would react completely with this 4 grams of O2. So on the bottom, I want the molar mass for oxygen. That's 16 for each oxygen times 2 is 32 grams of O2. That's the mass of 1 mole of O2. So I've canceled out grams of O2. My next stop, if you remember from the mass-to-mass stoichiometry video, is a molar ratio. So on the bottom, I want to look for the coefficient in front of O2. It's 5. So that means 5 moles of O2 reacts with 4 moles of NH3. So there's my molar ratio. This gets me from moles of one substance to moles of another. And then my final stop is just to use the molar mass of NH3 to figure out what mass of NH3 we're talking about. So a mole of NH3 weighs what? Well, a nitrogen is about 14, a hydrogen's about 1, there's 3 of them, so 14 plus 3 is 17 grams of NH3. You know, the more precise molar masses you can use, the better your result will be. But to illustrate this, I don't need crazy specific molar masses. Okay, now I'm ready to calculate. So I've got 4 grams times 4 times 17 over 32 over 5. I'm skipping over the ones because they don't change your math too much. And what I end up with is this. 1.70 grams of NH3 is needed. Well, let's look at how much NH3 is available. 2 grams. Well, that's more than 1.7 grams, and that's all I need to react all 4 grams of oxygen. So what that means is NH3 is my excess reactant, and O2 is therefore my limiting reactant. All 4 grams of O2 will react with only 1.7 grams of the other reactant. There's more of the other reactant there. So that's how I know this is my excess reactant and this is my limiting reactant. Now, a very common follow-up question to this is this: how much of the excess reactant is left over? And in this case, all you really have to do is compare the amount of your excess reactant to how much of the excess reactant was needed. I have 2 grams present. I only need to use 1.7 grams, and so this just becomes 0.30 grams left over. Let's do one more question about this. It says, how much water can you produce given these reactant quantities? So I had 2 grams of this and 4 grams of this, and I was able to determine that this was my limiting reactant, LR for limiting reactant. If it's asking how much of a product you can make, and you're aware of which reactant is the limiting reactant, you want to calculate how much of the products you can make from the limiting reactant, not from the excess reactant. Here's why. The limiting reactant is going to run out and limit how much of the products you can make. So you want to use this mass in this example, 4 grams of O2, to calculate how much water you can make. So let's just do one more mass-to-mass stoichiometry problem. 4 grams of O2, I'm going to multiply by the molar mass. In this case, the molar mass is on the bottom, so 32 grams of O2 there, 1 mole of O2 on the top. It should all look identical to your first setup here. On the bottom, I want 5 moles of O2. This is the molar ratio, this fraction here. So 5 moles of O2 to, in this case, 6 moles of water. And then the final fraction is the molar mass of water, so that I can cancel as I go here. And now I'm in moles of H2O. On the bottom is going to be 1 mole of H2O. And on the top is going to be the mass of that 1 mole of H2O, which is what the molar mass is, 18.02. 18 is probably just fine as well. Okay, so let's do one more calculation. 4 times 6 times 18.02 divided by 32 divided by 5 gives me 2.70 grams of water. What did we just calculate for? Well, the question asked us, given these reactant quantities of 2 grams of this, 4 grams of that, how much water can we make? And we chose the limiting reactant to do our stoichiometry calculation with because that's what's going to be completely available. All 2 grams of this is not going to be used up because this 4 grams of O2 will run out. So I want to use the limiting reactant to do this calculation. When I run that through, I get that I can make 2.70 grams of water. So that's it. That's limiting and excess reactants. In some reactions, you'll get a reactant that limits the process. And that means that all the other reactants are in excess, that there's some left over. It's kind of an interesting concept. And maybe the most cost-efficient way to set up a chemical reaction is to do the calculations for your reactants in advance so that you're mixing together exactly the right numbers of your reactants so that you don't have a limiting or excess reactant in the end. All you have is product. I hope this helped. Thank you.
(1.3b) Define limiting reactant and percentage yield. Definition of the limiting reactant is reactant that is completely consumed in a reaction and limits the amount of product formed. So, limiting reactant is the reactant used up first in a reaction or reactant that completely consumed before other reactant. This limiting reactant determines the amount of product formed because when the limiting reactant completely consumed, the reaction was stopped. Let's use simple analogy to understand more about limiting reactant, the cheese sandwich. To make one cheese sandwich, we need to have 2 slices of bread and 1 slice of cheese. So, bread and cheese are reactant and cheese sandwich is product. The stoichiometry ratio to make cheese sandwich are 2 1, 1. 2 slices of bread react with 1 slice of cheese to produce 1 cheese sandwich. Let's say we have 9 slices of bread and 3 slices of cheese. Which one is limiting reactant, bread or cheese? Let's figure out the answer. 2 slices of bread need 1 slice of cheese to produce first cheese sandwich. Another 2 slices of bread need 1 slice of cheese to produce second cheese sandwich. Next, 2 slices of bread need 1 slice of cheese to produce the third cheese sandwich. Now we got the answer. The limiting reactant is cheese because completely consume and limits the cheese sandwich production. And slice of bread is called excess reactant because remain after the reaction. Definition of the percentage yield. Percentage yield is the percent of the actual yield of a product to its theoretical yield. The formula of the percentage yield is percentage yield equal to actual yield divided by theoretical yield times 100%. Actual yield is the amount of product actually obtained in a reaction, and theoretical yield is the amount of product predicted by stoichiometry calculation. That's all. Thank you.